Let's take a look at a few more practice questions related to probability distributions. Our question here says, a hand in the game of hearts consists of 13 cards. What is the probability that your hand contains 5 hearts and 8 non-hearts? Now, first thing we need to figure out is what kind of question is this? We've looked at a few different types of distributions. We've talked about uniform, where all our probabilities are equal. We've talked about binomial, where we have independent trials with replacement. So if we are choosing something, we're putting it back, and our only two outcomes are success or failure. And we've talked about hypergeometric, where we also are looking at success or failure. So we define our variable x to be success. So are we going to get the value or the outcome we're looking for? And that's without replacement. So I'm not going to be returning balls to the bag I'm selecting from, and I'm not going to be returning cards to the deck. So if I'm being dealt a hand of 13 cards, I'm not putting those cards back in and choosing a new one each time. I'm not choosing 13 individual independent cards. I'm choosing 13 cards in a row from the deck. And so as I select one, if it's a heart, suddenly there are less hearts left in the deck and less cards in total left in the deck. And so the probabilities of drawing any given card are going to change. And so that means that in this case, we are going to be dealing with, in this case, we are going to be dealing with a hypergeometric distribution. With that in mind, let's write out our equations to help guide us as we set up this question and solve it. Now that we have our equation, it might help to define our variables. So n is like our population. Let's fix that. Slight mistake, but we haven't written anything wrong yet, so we can fix that really quick. It's a choose x. All right, now we can fix this up. So n is like the number of items in our population, or that we're choosing from. A is our number of successful items. R is our number of trials. X is our number of selected successes or successful trials. And I think that's it. So let's take a look at our question. Let's define our variables. So first of all, a hand in the game of hearts consists of 13 cards. So how many cards are we going to be choosing? How many trials are we going to be performing? That's 13. So let's write down R equals 13. Let's find our value A. What is our number of successful items? Well, we are drawing out of a standard deck of cards. There are 13 hearts in a deck, so A equals 13. And let's define X right away. Let X, our success, let X be the number of hearts in your hand. So we're counting our number of X's number of hearts. So A is our number of hearts in the whole deck, the number of hearts that we can select from. So we have A, R, X is our number of selected successes, and we're trying to look here in the question. It says we want to have 5 hearts, so X is equal to 5. So we're going to draw all our cards. 5 of them are going to be successful. 5 of them are going to be hearts. And finally, N, what is the total number of cards we are choosing from? And that's going to be 52. What do we need to find? We've listed all our given information. We need to find our probability. Actually, let's be a little more specific here. We need to find our probability that X is equal to 5. So we have all the information that's given. We know what's required. You might remember in class I talked about GRISA, given, required, equation, solve, answer. And this is a useful guide. It's still good to understand what we're doing, not just plug and pray. But it's still a good tool to help us make sure we've gone through this step by step. Next is our equation. Let's write our equation out and let's plug in our values. So, probability that X is equal to 5, or the probability of having 5 hearts in our hand, is equal to A, that's our number of hearts in the deck, so the number of hearts in our population that we're choosing from. Just like in the other video, it's like the number of a given type of fish in our tank is 13. So there are 13 hearts to choose from in the deck. We are going to choose 5 of them. So how many ways are there to choose 5 hearts from the 13 that are in the deck? Times how many non-heart cards are there in the deck? Or in other words, if our total population is 52, we've already considered the 13 hearts. How many non-hearts are left in the deck? 52 minus 13 is 39. Choose, and we want to choose a total of 13 cards. We've already chosen 5, so we need to deal with our 8 non-heart cards now. All right, and on the bottom, we need to know the total number of ways of choosing 13 cards from our deck. So we're going to have how many cards are in the deck, n, or what's our population of cards? It's 52. Choose how many cards are going in our hand. How many trials are we doing? 13. All right, that looks pretty good. Let's solve. So let's type that in our calculator. And once again, if possible, I do recommend typing this in all at once so it can simplify and just give you the answer. Some of these numbers individually are pretty large, and then if you start rounding as you write things down on paper, your answer might not be quite as accurate as it should be. And if we go ahead and do that, we're going to get an answer of approximately 0.125 or 12.5%. And so just to review and reflect here for a moment, this chunk deals with our successes. How many successes exist in the entire population and how many are we choosing? And the next chunk deals with our failures. How many non-heart cards are there? How many are we trying to choose? And choose is the ways of selecting them. And on the bottom, this is our total population. What's our total number of cards? Choose, what's the total number of cards we want in our hand when we're done? We've gone ahead and done our calculation. We identified our variables. We figured out what type of distribution we needed to do. Final thing we need to do is answer or write our concluding statement. Therefore, the probability that your hand contains 5 hearts and 8 non-hearts is approximately 12.5%. Let's take a look at our next question. The faces of a 12-sided die are numbered from 1 to 12. What is the probability of rolling 9 at least twice in 10 tries? Now, we're going to look at this problem, and the first thing we're going to notice is that we're talking about a die, and we know that when we roll a die, the chances of landing on any given value are equal. The probability of getting a 1 is equal to the probability of getting a 2 or a 3 or a 4 and whatever else. So we're like, oh, okay, that's uniform distribution. But look carefully, we're doing more than one trial here. It's not the probability of rolling and getting a certain number. We were asked, what is the probability of rolling 9 at least twice in 10 tries? So what we're going to do here is we're going to have a series of independent trials. I'm going to roll once and get a value, and then a second time, and a third time, and a fourth, and so on. And we know that the value on a given attempt does not affect the value on the next attempt. So if I roll a 1, the probability of rolling a 1 on my next attempt is not changed in any way. It's still 1 out of 12. And then for my third attempt, what's the probability of rolling a 1? It's still 1 out of 12. We have independent trials here. The probabilities are not changing. They are independent of each other. And our outcomes are going to be success or failure. In terms of success is going to be rolling a 9. Failure is going to be rolling something that isn't a 9. So this tells us, because it's fair, independent trials, we're going to be dealing with a binomial situation here. So let's write out our formula for the binomial distribution and then go ahead and set up our question. We have our formula written out. Let's start by defining our random variable x. So let x represent or be the number of 9s rolled. And the question said rolling 9 at least twice in 10 tries. So we're going to find the probability that x, so our number of 9s, is greater than or equal to 2. And this is where it gets a little tricky, because what are my possible outcomes here? How many 9s can I roll? Well, I'm doing 10 total trials. I need at least 2, so the probability that x is equal to 2 or the probability that x is equal to 3. I can't have 2 and 3 nines at the same time. I can have one or the other. It's an or problem, so we're going to add, plus probability of x equals 4, plus probability that x equals 5. And we're going to go all the way up to 10, plus probability that x equals 6, plus probability that x equals 7, plus probability that x equals 8, plus probability that x equals 9, plus probability that x equals 10. And this is the direct method, the direct way of solving this, because we are counting every case that matches our success criteria. We notice right away this is kind of a little clunky. Like, I'm going to have to do I'm going to have to do 9 separate calculations here. I'm going to do this equation 9 times. I can, but that's really annoying. I don't want to do that. I want to find a more efficient way of solving this problem. And so what do I know? What are all my possible outcomes? How many number of 9s can I have in total? If I made a probability distribution table, my outcomes, I might as well go through this here. My possible values of x are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Because I'm doing this up to 10, I'm doing 10 trials. And what do I know about all my probabilities? I know they're going to add up to 1 or 100%. So I know this chunk right here where x is greater than or equal to 2 is going to represent some chunk of the probabilities. So let's call that probability of success. And this chunk right here is my probability of failure. And I know these probabilities add up, so the probability of failing plus the probability of succeeding is 100% or 1. And so instead of calculating this whole chunk here, maybe I can just calculate this chunk here and then find the difference. So like literally find the difference. Probability of failing is equal to 1 minus the probability of success. So if I can find the probability of failing indirectly, or then I can find the probability of success equals 1 minus the probability of failing. So let's find this value instead. It's going to make our life a little bit easier. And in this case, think about what the question is asking. What does it mean to fail? Failing means having less than 2 hearts in the hand. So we're going to find the probability of x equaling 0 or x equaling 1. So let's write that out in our probability notation. Probability that x is less than 2 is going to be the probability that x is equal to 1, or, so plus, probability that x is equal to 0. And we already know this is a binomial situation, so we're going to use our formula that we have up here. So let's do it for our 2 situations here. For situation x is equal to 1. So we're going to have n. How many trials are we performing? Actually, we can define our variables here. N is 10. X is going to change. Probability of success is 1 out of 12. And Q, probability of failure, is 11 out of 12. And we notice that P plus Q is equal to 100%. And that's just like we just talked about the probability of successes and the probability of failures adding up to equal 100%. So just as an extra aside, we kind of see that happening here as well. Let's plug our numbers in. So our number of trials is 10. Choose, and I'm testing for x equals 1. So 1. Probability of success is 1 out of 12. And we're testing for that to happen once. Probability of failure is 11 out of 12. And we're doing 10 trials. We've already counted one of them as a success, so there are 9 left to consider. Let's do our second term. Plus, once again, from 10 rolls, we are choosing 0 successes, probability of success to the power of 0, probability of failure to the power of what's left. 10 minus 0 is 10. Let's go ahead and calculate those values. And our first term is going to be equal to approximately 0.381. And our second term is going to be approximately equal to 0.382. 419. Let's add those together, and we will get a value of approximately 0.79999, or let's just put 0.8, or approximately 80%. Oops, x is less than 2. And remember what we said before, our probability of success and our probability of failure are going to add up to 1 or 100%. So our probability of success plus our probability of failure, which we just calculated, are going to add up to equal 100%. I don't know my probability of success yet. I'm going to calculate that. I just found my probability of failure is 80%. And so if we do this calculation, I'm not going to show all my work because it's just basic math that you can all do. 100% minus 80% is 20%. And this question is from your previous homework. So if you've gone back and checked, the back of the book actually says, I believe, 0.2003 or 20.03% probability of success, which in this case is rolling 9 at least twice. But we rounded a little more vigorously. We don't have as many significant figures. Let's finally answer our question with our concluding statement. Therefore, the probability of rolling 9 at least twice in 10 tries is 20%.